Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Guillermo Marcillo. Cover crops are known for their ability to provide economic and ecosystem services to farmers, including, for example, impacting soil nitrogen. But how much nitrogen exactly can cover crops add or remove, and how do we find out? In this episode, Guillermo joins me to discuss his work collating research data to get to the bottom of cover crop nitrogen replacement values. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Guillermo Marcillo with us. Guillermo is an assistant professor of plant sciences at West Texas A&M University. He received a PhD in crop physiology and production from Iowa State University. Previously, he attended New Mexico State University and Escuela Politécnica del Ejército in Ecuador, his home country. He has worked on varied topics related to cropping systems, productivity, and sustainability across different regions in the U.S. Hello, Guillermo. Welcome to the show. How are you doing today?
Hi, Abby. I'm very happy to be here today. Looking forward to engaging in fun, exciting conversation that could be of interest for your listeners.
Yeah, me too. So to jump right in, we are talking about a show favorite today, which is cover crops. So to get us started, can you just tell me more background about just a light refresher for any new listeners, what cover crops are, how they work, kind of what you were hoping to address in your research?
For sure. Cover crops, first of all, was one of those strategies of management that happened here in the United States and have been in place for a long, long time. And this is something that is known worldwide. So back from when I am in the Andes in Ecuador, we know those things, right? So it's been common knowledge from our ancestors. So the whole idea of cover crops is basically just to keep something in the soil during the months where there's nothing growing, right? Where there's no cash crop to be harvested. The idea basically with cover crops is to not economically, like immediately, but it's more in terms of conservation and more in terms of what you can put back in the soil so the cash crop can benefit from it. And the terminologies might vary. Some people think that cover crops is kind of an old school terminology. Some people call them now ecosystem services crops, things like that. But, the best way that I can put this simply is that cover crops are alternate species that grow in between cash crop seasons, along cash crops, and sometimes with the main interest in providing services, right? Ecosystem services, economic services that are very varied. That's it. I think that, I don't know if that's comprehensive enough. I can dig deeper if you want it, but that's the best way that I could interpret a cover crop, what it is.
Yeah, no, I think that's a great high level overview of what they are. So in this one research project specifically, you were hoping to kind of gather a bunch of data to really drill down on one specific ecosystem service, which is kind of helping with nitrogen issues. So could you tell me a little bit more about kind of the scope of your project and what you were looking for here?
Yeah, for sure. Absolutely. And then, kind of a fun story before we got into that. This project happened by the time that I was doing a postdoc with the USDA in Beltsville, Maryland. A little before that, I have completed a PhD in Iowa State, where I studied cover crops for a good part of my dissertation. And while I was in Iowa, one of the big main questions was understanding, first off, what are the different ways in which cover crops can benefit the cash crop, corn, soybeans. And one of the number one complaint among growers and the agronomy community in general is that cover crops are good, but how good they are, or whether, or in turn, if cover crops rather penalize the cash crop, right? In other words, if they're competing for resources, and if corn or soybean, whatever the cash crop yields more or less with a cover crop. So some people say, or used to say, I don't know if they keep saying that, cover crops are good, but they bring down my yields, right? And at the end of that period of the study, we somehow understood things well in some aspects, but there were other questions that were definitely unanswered. And one of those was what happened with the other pieces of the cake, right? Other pieces in the system. And nitrogen, which is kind of the main cornerstone of this conversation today in the podcast, it happens to be the number one input maybe among growers when they are planning the growing seasons. And, biologically, plants need nitrogen, right? Plants need nitrogen to function well, and of course, growers know this at the end. If you put more nitrogen in the soil, then it's expected that your crops are going to yield better. They're going to yield more. Now, nitrogen, if that's too much, if that's just a little, that could be a problem, right, for the crop itself or for the environment. And this, again, is something that has to be analyzed region by region across the states. There are some parts where the problem might not be that much, but in other places definitely is a concern, right? And by the time that I was in Iowa, for example, in the Midwest, and all those people know this, and there's a whole lot of concerns about water pollution, right? Pollution with groundwater. If there's too much nitrogen or that is not taken up by the cash crop during the growing season, then you have a lot of different issues with water quality. In other places, like I am right now, I am in Texas, there's not a lot of competition for nitrogen, I would say, but there's water, right? Water is not enough, right? And just in order, and the cover crop competes with water. But getting back to the point of the nitrogen thing, one of the main questions that people have is, I know that depending on the species that I choose or select for my cover crop, the cover crop can actually take some of that nitrogen available in the soil, plus the fertilizer that is put in the soil. And that can sort of be a transfer credit of nitrogen for the next crops, right? Or some of that nitrogen can be taken up by the cover crop and never released back to the soil. So the big question here is just to see if we can put some measure of value on that amount of nitrogen captured and or released from the cover crop, and if that could be any sort of benefit for the cash crop. I think that that's the context of this project.
Yeah, absolutely. So kind of comparing how different cover crops interact with nitrogen on whether they're going to take too much and compete or maybe put some back in the soil to be helpful, and ultimately to do that in a way that would potentially influence how much nitrogen fertilizer might need to be added. So specifically, there's a term that you use for this in the paper called nitrogen replacement value. So could you just real quick define how that's calculated?
Sure. That's a terminology that has been in place for a long time. And, in simple terms, what I could understand, at least my interpretation of replacement value, is when you are comparing two different practices, right? One, which is an amendment, and the other control or not amendment. The nitrogen value or nitrogen replacement value is the amount of inorganic nitrogen that is provided with amendment to replace the no amendment situation and for yield to be the same, right? So in other words, if there's supplementary nitrogen that is provided by the amendment and still your yields are at the same level, right? That's kind of the basic interpretation of the nitrogen value. Now, if you're kind of curious now about how we end up calculating the nitrogen replacement value in our paper, what we did was, I don't know if you want me to go there right away,
please,
and describe it. So the whole process involved other collaborators in this project. And we pulled information from many, many different papers that were out in the States. So as I said in the beginning, the idea of replacement value has been around for a while. And some specific papers have published their results. There's a lot of amount of anecdotal evidence, of course. what makes this project unique, I think, was the idea of averaging things out, if you want to say it in that way, and compile all that information available, those little pieces of the puzzle, and see if there's some common trend in terms of major addition of nitrogen to the cash crop by the cover crop. And so what happened is that in these papers, a lot of researchers have, of course, different questions behind those experiments when they lay them out. And the common thing to all of these studies that we focused was that they have treatments or they have experiments or they have plots or fields on cover crops, and they have fields without a cover crop. And plus, after the cover crop, they have a corn or maize, right, treatment. And the beautiful part of this pool of information is also that both treatments were fertilized. And that's sort of a very precious data set in the way that not all the time you have cover crops plus fertilizer. Or if there is, not all the time people record all these important variables of interest for agronomists, right? So now that we have all that data with cover crop and without the cover crop, fertilize at different rates, increasing rates, then you can sort of graph out the response of how much yield you get by increasing unit of nitrogen. And, as growers know, as agronomists know, that response is pretty fast at the beginning, then sort of stabilizes, reach a maximum point probably, and then just vanishes out, right? This is the hypothesis. And when you compare these two responses, with and without the cover crop, you can sort of mathematically and statistically interpret or identify the point at which the two curves reach the same level, the same amount of yield, but then you need to find out what are those nitrogen rates, right? So in other words, you're looking at the nitrogen rates with cover crop and without cover crop yielding the same or leading to the same yield. And then that's going to be the difference, right? How much of that nitrogen is supposed to be added up by the cover crop or not. I don't know if that's enough.
Yeah, no, that makes sense. So you're basically comparing how do I get the same amount of yield either through a certain amount of fertilizer or by hopefully a smaller amount of fertilizer and the cover crops just replacing what you would add.
Right.
So I have a lot of questions about this.
No, for sure. Yeah.
So my first thought is because I know you mentioned that, too much nitrogen in the soil, especially in forms that are maybe not plant available, are potentially have can have like an environmental effect that is bad. Right. So so then I'm wondering, like, if you have a cover crop that is adding nitrogen to the soil, like it, to me, I'm like, oh, well, you would want it to replace a lot of nitrogen, but like, is there a potential for a cover crop to potentially have a negative impact by adding too much nitrogen? So basically the question is like, this nitrogen replacement value, it's not like you're always aiming for like we always want it to replace this amount, because it's all contextual to like what you need, right?
Absolutely. Yeah. No,
whatever the question is in that.
No, it's a very, very fun way of structuring your thought in a way that it's all of these ideas, right? Some a little simple when you put them in paper, but even if you get to test me right now, all the specifics and all what's behind the story of cover crops and nitrogen replacement, where there's a lot of unknowns yet, right? Absolutely, you got up one point that is very important to mention, right? So overall, we're gonna dig deeper into the results in a few minutes, but and growers know this, right? The biology of the different species that people target as potential cover crops has a lot to do with what to expect with the results of the nitrogen replacement value. Absolutely, there are some species that are more fibrous, right? That are more in other words, less prone to rapid decomposition and release, right? Which is, what grasses basically, right? Very hard stuff. And those tend to be very, very vicious about their nitrogen consumption, right? As well. In the end, if we were analyzing this whole idea with corn and cover crops, grasses, corn is just a big grass. So there's some of that. And grasses are not very much friendly with their nitrogen, right? So they're kind of, I took my own, I don't want to share that with my neighbors, right? But there are other species that bear the second largest group that are used are legumes, right? And legumes, they are not very nitrogen friendly. They are they do and produce their own, right? They fix the nitrogen that's available in the atmosphere, and through different mechanisms in the soils that they make it not only usable for them but available for others, right? And they're pretty much friendly with that. They like to share their nitrogen with other crops, right? So if we keep that idea in mind, and depending on the region where those crops are growing, depending on the rainfall conditions, how much water is that for nitrogen to be mobile, you have a water in the soil. You can expect that some of that nitrogen that is captured by the grasses in this case are not immediately available, or not ever available for the cash crop, right? And depending on, I'm not also a soil expert, but the baseline condition in which the two crops are grown, or the large history of management in a certain plot or field, determines also, if the nitrogen situation was good to begin with, right? That affects a lot of things. But at the same time, with the legumes, you would expect to have some sort of always a positive replacement, right? Just because of the fact that there's much more nitrogen added in the system by the decomposition, which is faster. And then the whole idea also behind the paper is that if farmers strategize a little bit and thinking advance how much they're going to let the cover crop grow, too big, too short, those are not ideal scenarios. You might kind of reach that sweet spot where the nitrogen amount is what the cash crop needs, or at least some of that fraction that sort of alleviate, the nitrogen budget, right? The nitrogen, the actual fertilizer budget for a season. That's what I could answer for your question in that one.
Yeah. I love this because I just think one of the things that I always love about learning about how farmers make their decisions and all this complexity is just that there's always context. There's never like a silver bullet. Right. There's never just one answer. I imagine if you have a bunch of legacy N that's causing problems, like maybe you want it to be taking up nitrogen that, is causing problems and all that kind of stuff. So I love that. And then the other thing that I really appreciated about this research is that it felt like it was kind of working backwards from a lot of the other types of research we feature on here, which is like, hey, we'll test adding the nitrogen and see what the yields are. But in this case, you're kind of working back from, we know what the yields are under these conditions. Let's kind of work backwards to see what we can figure out. So big fan of that. So, I'm wondering if you can just tell us a little bit more about anything. Well, first of all, anything you want to add about that, or just like your gathering process, how you found these papers, you mentioned some of the criteria that you needed, but anything else like that, size of the data set, anything like that.
Sure. Absolutely. Yeah. When we got our hands dirty with this data, by the time that I sort of take the lead in this, there was my other co-author there in the paper, Dr. Rachel Tapa, who unfortunately wasn't able to reach to join the conversation today, but he's a really, really good friend and a really good colleague. And we were working together on the Bellsville station by the time, and he did a lot of really good work in compiling the first papers. he basically shared with me this idea. Before working on this project together, we have already published other papers around the cover crops theme. And one thing that gets us to really synthesize this type of project was that we are, we do crop physiology, we do soil science and all of that, but also we're very crazy people about modeling and statistics and whatnot. And in some of our previous publications, we have dealt with different statistical methods for compiling data. So this was one project that just fits the mold with that. And so the screening process was very typical of what, I wouldn't want to call this a literature review because it's more quantitative, but perfectly we follow the standards, right, for a good lead review. And we screen papers basically focusing on the continental US. We took a look at the management and the geographical conditions of those experiments. And that's a very important thing to mention as I'm describing the methodology, because as you said, there's not silver bulletproof. There's not, one recipe that works every time. The readers have to be very mindful about what are the limitations of this project, right? And some of these are experiments, right, conducted in research stations where there's a lot of control. And but still, there's very valuable pieces of information that sort of help us to round out the equation fully, right? And then, of course, we were pretty much careful to include things like the nitrogen management of those experiments, of course. There was a whole lot of observations or experiments or papers, right, that they do a very typical split application, right? At different stages of the growing season. The method, right? Some of those were pretty much like mechanical applications with incorporation. There were some, I think, anhydrous ammonia stuff, something kind of fancy management, but there was not the whole piece. As I said, geographical and climatic conditions, those affect, of course, absolutely, and drive much of the variability in agricultural experiments. And of course, the yield and the nitrogen rates were basically the central pieces in the information. So a whole lot of screening, reading, separating papers that might not have all the information that we want. But at the end of the day, we were very happy with the lead review. We were able to represent at least 11 sites that were part of, the major corn producing regions in the United States. And absolutely, there were some, overdominance of some particular areas of interest for us in the project at the time. Like, if I remember correctly, there was a whole lot of info or data coming from the Middle Eastern United States, which, it was pretty seminal in the way that a lot of research in cover crops, in legume cover crops, come from the 60s, 70s, on the Maryland area. And there were, of course, a whole lot of more papers coming from the Midwest, right, the upper Midwest, a lot of grasses. I don't know if this is something that your listeners would be interested in hearing, but a lot of research in grass cover crops coming from the Midwest. I'm talking about the years 80s and on and on and on. So it's very interesting to know just that, different periods of time, researchers were focused on a particular theme, on a particular question about the cover crops of the species that were involved, and there was clearly some kind of separate effects, right, in their questions, right? But as I'm saying, at the end of the day, the data set is pretty much comprehensive, has its limitations, but at least put you in good shape to at least delineate some trends, right, and some important averages, and this is something that the readers can just attest by themselves by reading and looking at the papers. We're very cautious in terms of coming up with conclusions. We explain a lot of things there, but we kind of warn the reader or alert the reader that cover crops are pretty much site specific. And whatever works in one area is not going to work 100% in others. And, neighboring farms even might not get the results that, one gets. And that's somehow implied in all of this.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Guillermo's paper, The Nitrogen Value of Cover Crops, How Much N Can Cover Crops Replace, published in Agricultural and Environmental Letters, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. With all of those kind of caveats and cautions in place, what did you find? What were your results?
Yeah. So overall, one part, I would say that the results were pretty much confirmatory, right? What some of these specific papers have been describing on their own. And the major result of this study that we conducted was somehow averaging all of those, capturing all these different nuances of those papers. But the trends were clearly, and grasses were much more associated, correlated with decrease in replacement value. And that would be it could be twofold. So one is basically just the obvious yield penalty limitation of the grasses and the competition factor that I mentioned in the beginning. And, then the very strong tendency of the grasses just to tie up the nitrogen in the soil, that might be one of the factors. And we put a number there that on average, we found at least, grasses to be responsible for a penalty, for more nitrogen needed, right? Which is in the amount of 25 kilos per hectare, about 20, I think that's bushels per acre, 20, I'm not doing the math correctly right now, but that's in that range. And legumes, on the other hand, overall, were associated with a much more active tendency to provide additional nitrogen, right? Which what we would call a positive nitrogen replacement value, in the range of 50 to 60 kilograms per hectare, right? That's a big average across all these studies, of all these observations. And the reason being, in the case of the legumes, precisely this biology that we sort of touched upon in the beginning of the conversation, that they're the very mechanisms of these species just to capture some of the atmospheric nitrogen, do a whole lot of syncing with the processes below ground, and then getting that nitrogen available, right, in mineral form for the corn to take up. So those were the very strongly, statistically robust results, if you want to say it that way. Then in the paper, we sort of discussed the possibilities or different scenarios in which these things could have come to place. And we also described there, right, a very much site-specific nature of doing cover crops alongside the cash crops. And as I said before, also, right, that there's the factor that, a little bias, if you want to think of them that way, in terms of the number of observations coming from a specific region. But by the same time, when you get to publish your work, you always get the peer feedback, and all of those, disclaimers are available in the paper for those interested. So the other thing that is important to mention, I think that's a result that has some obvious implications for management, for crop management, for nitrogen management, is that knowing that at least 40 kilograms extra, right, for potentially available nitrogen, or replacing inorganic fertilizer by the legume cover crop, could mean dollars, right, in terms of fertilizer amounts that the growers schedule in their operations. Whereas the grasses, just because of the fact that the grass is associated negatively with some loss in value, that doesn't mean that the grasses are not to use, right? What that would mean is depending on the area or what the region is implied. Nitrogen just can put a little, some more, right? Some more. I think that there's a whole lot of different situations that can just be in consequence with this, right? Because then you have to think about, is that really over excess of nitrogen going to affect environmental variables or indicators of different sorts? Absolutely. The paper didn't want to go there. We have our reaches or boundaries in terms of discussing these economic and nitrogen value, right? But if there's anything that I can think important is just thinking in terms of the economics. And I mentioned this because by having conversations with different colleagues, I've had also the chance to collaborate with people in different disciplines, in different spheres. There's, some friends in different farmer support groups that have been playing along with cover crops for a long time. There's some economists that have been part of different projects that I've been involved in. And economics is something that has been, on the radar for a long, long time. And there's not a whole lot of agreement yet in terms of what is the actual economic value of the services provided by the cover crop. So in this case, we're discussing nitrogen. This is one of many possible attempts. And this is something that we put at the end, I think, in the paper. Most of the time when we think about this in terms of policy too, right? And we are going to enact or propose new alternatives for cover crop management, of assistance, federal programs, things like that. The number one metric that people used to talk about is just the yield penalty, right? So how much yield is dragged or how much yield is pushed by the addition of a cover crop. But based on this research, I think we can consider the nitrogen replacement value in some form. It's not a universally accepted metric. It has some people that, in the way that we calculate it, some people would say, well, that's not really replacement value. That's something that more, some people would call it a nitrogen savings. Some people call it that way. This is not a study that has, boundary conditions defined clearly in the beginning, like one single mother experiment where we do our calculations under one single set of assumptions, set of conditions, and we didn't track the whole biochemistry, right? The whole release, switch off, switch on of the nitrogen in the soil. Absolutely. This was more like a statistical exercise just to provide some robust estimation of this number. And then getting back to my previous point of policy, I think that could be important to have these topics in conversation when we talk about cover crops, absolutely, and sustainability in general, I think.
Yeah, I think when, we've had people on to talk about, sustainable methods or moves towards more sustainable agriculture, organic farming, things like that have practices built into them that are potentially more helpful for the environment. And it's always hard because, sometimes there is a strain on the farmer to implement practices that don't have a direct, like, monetary outcome, right. Because it's helping the environment, but isn't necessarily helping yield or, whatever. Yeah. So it's always fun to see those kinds of considerations brought in of, how do we make sure that this is environmentally friendly, but also like farmer friendly in an economic sense. So I really like bringing that into play. And also just that this feels like it's such fertile ground, I guess, pun intended, for further research that can, better quantify these or, like you mentioned, you're kind of starting from all of this disparate data. How can we then, if this is reverse engineered, how can we forward engineered to quantify these effects. So I love all of that.
Yeah.
And I think, well, before we move on to future research, which I think is a great time to talk about it, just to better round out our image of what was included in this.
Yeah.
I know cover crops are sometimes grown alongside the cash crops. Sometimes they're just like in an in-between season. And I also know that sometimes they're grown in mixes versus just by themselves. So can you tell me about whether, like, if there was any restrictions for the data that you were looking at as far as either of those
absolutely,
kinds of factors?
So for sure. And then, I think that it was all in our interest in the beginning when we were proposing this project to have data set that is as representative as possible in terms of, the different management, the different species and all in all. And unfortunately, by that time, I am talking about that time, this came out by 2017, 2018, I think, but it started all the way back from the 2016, and all the literature published on this aspect was pretty much limited to either or. So it was grasses or legumes. Absolutely, there was a whole lot of papers that were around in terms of polycultures, polymixtures, all of those different things. But those situations in particular were not having the experiments fertilized, which was a major drag, right? And there were, I think, one or two that the data which is not basically fitting, right? And we have to exclude them. And, when we were getting the whole process of review of the paper and we were getting the feedback from others at the same time, they ask the exact same question that you have. And, the only thing that we can do in those circumstances is just play with what we have, right? And then mention, in passing that, right, it could be a really rich question, right? For some of those of our active listeners, maybe there's some potential grad student, behind trying to get to a good project in the future. It would be like the polycultures, mixtures, alternative or more aggressive methods of management. How does affect this whole conversation of cover crops and questions like that? Because it happens also when you are in a project like this, you want to, in the best interest of being comprehensive, you might want to capture everything. But at the same time, you cannot just mix, apples with oranges, right? You have to restrict. And for that reason, we kept that separated with legumes and grasses only, fertilize it, and that's it. And of course, with corn following, one of those possibilities too. To my knowledge right now, I'm not 100% sure, but I don't remember having experiments in particular that have some sort of intercropping of, at least that I don't remember.
Okay. Perfect. Yeah, I just wanted to help continue to kind of set those limitations on what people can think of as having been included. So now we can move on to future research. Yeah. So we've kind of touched on a few areas, but where are we headed with this? What else can we still learn?
Oh yeah. Well, for once, I've been getting to work on other topics recently. I'm not that fully connected with cover crops that much. It's in my radar, absolutely, because I do have some conversations with other colleagues in terms of improving other different services, right? How to cover crops like soil health. All of those are different questions that I have. But if talking about environmental or geographical, conditions, right now I'm in Texas, right? And here in Texas, cover crops are touted as being good practices, as I said before. But in the particular area where I am immersed right now, weather is a very, very big concern. And I don't know if you're familiar with the Texas Panhandle and, all that part of West Texas in particular. So there's research that's been going on right now by some active groups among several colleagues of mine, and they always find this very, very pervasive effect of the cover crop penalizing the yields, right? And I'm talking here about other crops, of course, corn for silage, sorghum, and so on. So even at those very elemental level, those questions like yield competition, still there's a whole lot to learn in places like this, right? And again, this is just from my own limited knowledge in the area. I've been here for 3 or 4 years. I'm learning. In terms of also much complex characterizations of the nitrogen cycle involved with cover crops, with precision ag now, instruments, better instrumentation, sensing systems right now, digital technologies. There's fantastic work that has been out for things like species classification with imagery, right? Cover crops, detecting which is cover crop, which is not cover crop. Even in that arena, I think that there are things that people can do in terms of improving their resolution of imagery, or working with certain band width, right, in terms of the light spectra, and finding if that's very much beneficial to characterize nitrogen status. This is something that I would love to hear more. That's in terms of nitrogen question. Now, in terms of water, I would love to see a lot more coming on in the next years. Systems, right? I'm a crop physiologist, pretty much formed with the idea of systems and high-level thinking questions, right? Interconnections that happens at the different scales, atmosphere, the plant itself, the below ground, and all the other possible connections that are out of the farm, right? Which is the economics. We were discussing economics before. The societal aspects of grower and land relationships. There's a whole lot of interest on my own personal program in terms of understanding young farmers and young generation of farmers. How do they feel in terms of this type of management, and new cropping systems adapted to different areas? You see that it's just like peeling the onions. Every time that you just peel one layer off, there's more and more inside. And I think that overall, what we want in the end is just to have some way in which we can produce more profitably, right, and more sustainably at the same time. And cover crops is one of those strategies, not the only one, absolutely. But I would love to see more work in those and on other aspects of the topic.
Yeah, absolutely. Sounds like there is just a ton of research that can still be done in so many of these areas. I have 3 questions left for you. First one is, if listeners want to learn more about any of the things that we talked about today, where can they go?
So there's so many different venues. So the one is just for people to be active listeners of shows like this, right? Podcasts. Being a citizen scientist is a very much needed in these times. And I think that people have to be aware of what's the work that we have been doing, and at the university level, at the industry level, farm support groups and things like that. So these podcasts are just fantastic opportunities for dissemination of some of the work that I think that we need to have some more connection between what we produce in the university and the land grant system, and of course our recipients of that work, which are growers, our consumers, and so on and so on. So that's one. Absolutely, just be aware of the work that extension and state agencies are doing. That's fantastic too. Ironically, I'm involved in a lot of different digital aspects of precision ag and things like that. But I'm very, very ignorant in terms of social networks and things like that. I'm a Facebook guy, but I know that there's some people, right, young generations that are pretty much taking advantage of the social networks nowadays. So it's good to follow those people. I could always make for you available some different links of different people that I have known over the years that I still connected in these topics. I could mention, in passing. I am Practical Farmers of Iowa, for example. There's a group of friends that have been working with that for a long, long time in the Midwest. There's Sustainable Agriculture. I may be giving you the wrong acronym, but these are the folks who I've worked with in Beltsville by the time that I was doing my postdoc. Had to mention some names there. Stephen Mirsky is a great, great crop physiologist, agroecologist. He was my mentor during those years. And he has a very cool ecosystem of, methods, alternatives for those interested in kind of integrating this to sustainability and digital services and all of that. Now I'm in Texas, as you mentioned. I'm in West Texas A&M University. Is a great, great space for education of potential future farmers, entrepreneurs, scientists, and we're working in a lot of water research. So I can put you some links of interest if you want to share afterwards with your listeners. And I'm sure, people just can Google me up. I think I'm in spite of not being very active in the social network world, I do have presence, in the internet, so people can know more about who I am and what I do.
Perfect. Yeah, we'll definitely include links to these things in our show notes. Mm-hmm. So then, next question, if people want to take the next step and get involved with any of the things we talked about today, what can they do?
Oh, that's a pretty hard question. I don't know if I am in the position to just give away recommendations or tell people what they have to do. The only thing that I can kind of preach on people is just that they have to practice, learn, relearn, make mistakes, and go on. I don't think that there's if we can think of this, we have this tendency to be over prepared or be over cautious about uncertainty, and certainly now we live in a world that is pretty much full of uncertainties and different aspects, right? Economical, societal, political, and so on and so on. And if we are always wanting to be prepared or ready for the right moment, that moment will never come, right? So we have to sort of be ready to take risks and challenges. Because again, just be this the first job for those of your long listeners, be this the first opportunity for something to be actively involved in, again, policy, production, whatever aspect of agriculture. You won't always be ready for that moment. You just have to take that opportunity when you feel it's right. And then you will do good. You will make mistakes. Absolutely. You can just relearn from them, and you just move on. So I think that's the only thing that would come to mind. But absolutely, again, in my attempt of sort of taking here the position of a scientist, right, in the university, and an educator, of course, I teach also. We are friends, right? For those of you listening, maybe our growers, our consumers, we're a friend. We're your friends. We're not supposed to know everything. We know some things. We have some levels of knowledge about different things. In particular, I know a little bit about something. There's a whole lot of topics and themes that I definitely have no knowledge, absolutely. And but if there's something that I like to mention to folks is that I'm never afraid of knowing more, and always, I feel amazingly happy just to share the little that I know with others, right? When I'm doing conversations with growers, in field days and things like that. it's just incredible, just the amount of knowledge that our growers have. And so I think that's it. There's still hope in this world if there's anything that has value in that sentence.
That is super sage, wise advice. Thank you so much for sharing that. I liked that a lot. So then, final question.
Yeah.
What is one fun fact that listeners wouldn't know about you if all they had was your research?
Well, it's that's something funny. That's always that I asked my students the first day of class, at the end of the class. I don't know if there's one unique funny fact about me. For once, I am a very, very fan of. This could be anything, right? It doesn't have to be work related.
Yeah, anything.
So for those who don't know me well, I'm a very avid runner. I like running a lot. I'm crazy about dogs. I love beagles, as you can imagine. I love those little monsters. And if there's something like interesting about me, I have watched The Office countless times. The American version.
Sure. Yeah. Man, several fun facts. Wonderful.
Yeah.
Well, this has been such a wonderful conversation.
Oh, yeah.
Thank you for taking all that data and kind of collating it into something for our readers and listeners, and all the work you continue to do as you have been moving on from that. So thank you for your time.
Thank you very much. I have enjoyed this conversation a lot of times. Happy to keep again having this conversation and conversations with others. I'm always available if you want to reach out. I'm sure that you will let them know where to contact me. Happy to take any future questions.
Absolutely. Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.